Okay, students, so we will start the class. Today we are moving to the another topic of power plant engineering, that is combined cycle power plant. So last few classes we were review the topics. Okay, already we have completed 5 units and some portions we have missed during the class time. The first and second unit some portion miss ஆச்சு அதை வந்து we covered last few classes and yesterday and today we are sorry. So already discussed topic we are reviewing. Okay, the last two classes. So that is we are uh, the plan. That is we are going to discuss some important areas. We are going to discuss other. That is our plan. Okay. So for yesterday we discussed about the concept of what are the concept we will discuss fuel ashes and then fluid bed fluid bed combustion chambers அப்படிங்கிற concepts we will discuss all the different types and what are the advantages of fluid bed combustion, everything we were discussed. So now we are moving to the combined cycle power plant. So this is also very important in unit 2. So in unit 2 you can uh, uh, you have to study, you have to go through the combined cycle power plant because it is very important. So that's why I take this topic as a reviewing topic, right? So first we will see the agenda of the today's session. So we are reviewing the combined cycle power plant. In that we are going to discuss about definition, introduction, basic concept, and what is the difference between Rankine and Briatan cycle, and how the combined cycle is operated, and how the power plant is are running. Okay, all those things we are going to discuss. That is the today agenda of the session. So you know very well combined cycle. There are two different type of cycle we were discussed. Okay, in the first two unit, one cycle is Rankine cycle, second one is called Briatan cycle. So the Rankine cycle concept is applied for your coal-based thermal power plant or steam-based thermal power plant. Here, mm, Brayton cycle is applied to the gas turbine power plant. So if you want to generate more power, mean we have to add this two cycle, that is called combined cycle. Okay, so combination of Rankine and combination of Rankine and Brayton. So this is called combined cycle. So with help of that we can produce more power. So in normally, if you go with a steam turbine with help of steam generation, okay, we can produce one power. In apart from that, we can additionally, okay, with help of the waste steam from the gas turbine, we can generate further power. So that is called a combined cycle. So with help of steam power plant and gas turbine, the combination with the help of these two, we can generate more power. So additional power, if you want to generate, mean we can go with combined cycle power plant. So what is the concept behind on combined cycle power plant? Means normally a combined cycle power plant produce high power output, that is I have told, at high efficiency. So maximum 55% power we can produce with low emission. That is very important. So if you want to control the emission, because normally in coal-based thermal power plant, due to the coal firing, the emission is come out from your uh, exhaust gas. So at the same time, the exhaust has some heat energy. That heat energy can be utilized, okay, with help of another plant or another cycle. Then the electricity is produced. So in conventional power plant, we are getting only 33% electricity, and the remaining 67% are waste. So if you add another one cycle means with help of the remaining 67% waste heat, we can produce power. So the overall combined cycle plant, we can get maximum production of 60% electricity capacity. So, an effective manner, we can get maximum up to uh, 55 percentage. Okay, so this is the concept behind on the combined cycle power plant. So, where it is located? So, normally combined cycle power plant is a large country-based plant. So, it is located in the northeastern state of US. Okay, with the help of this combined cycle power plant, we can able to generate maximum 726.6 megawatt. So combined cycle is nothing but a combination of two cycle power plants. So with the help of the two cycles, we can able to produce around 72 percentage of power. Okay, that is one unit is produced 363.3. Okay, so with help of the two unit, we can produce 726.6 megawatt. In that, a steam thermal power plant and a combination of gas turbine power. So with the help of gas turbine power plant, we can generate 232.39 megawatt, and with help of waste heat, additionally we can generate 130.91 megawatt. So if we operate two per unit, we can generate 726.6 megawatt. So this is right now it is running in US. The maximum production capacity of this power plant is 72%. So in US, it is a largest country-based gas and steel based power production company. Okay, this is uh, maximum in this we can generate power at 55 percentage. At the same time, 90 percentage of energy, heat energy, can be utilized for power generation. So this is more versatile than coal and oil. So in this slide, you can see the combined cycle power plant. First power plant is natural gas, run with help of natural gas. Here you can see the natural gas is taken from this source, okay, natural resource, gas sources. After that, it goes to the combustion chamber. So firing action or combustion action will be takes place due to the hot expansion gases is produced that will goes to the gas turbine. So gas turbine starts rotate. So gas turbine is generally connected with the GT generator. So if gas turbine is rotated means the GT generator also rotates. So power we can produce. This is one way of producing power. So after leaving the hot gases from your gas turbine is a waste heat. Okay, that directly goes to the atmosphere wind. Okay, that will not be useful one. Okay, so for that we have to utilize the heat. We have to utilize the heat with help of heat recovery system. So nothing but a heat exchanger unit that will be placed in uh, the out portion or exhaust portion. Okay, it will place. So what will happen? So due to the combustion, high amount of hot gases is produced from the gas turbine. After expansion process, the hot gases goes to the chimney. That time, with help of that heat recovery system, okay, the water is circulated in that area. So water gets heated up and converted into steam. That steam is goes to another one steam turbine. So again the steam turbine is rotated. So if due to the expansion process, steam turbine is rotated. So the steam turbine again is connected with another one generator, that is ST generator. So with help of that we can produce another one power. So by this way, GT generator and ST generator both are producing electricity. After that, the waste is goes to the condenser area. With help of cooling water circulation, water is get cooled and then it is converted into liquid state. Okay, from vapor to liquid state, and further it is moved to the heat recoveries area, and finally the hot gas escape from the gas turbine. Again, it touch with your heat recovery zone tubes. So in the tubes, you have a water, so water gets heated up. So this cycle is repeated once again. So by this way, we can generate two power. One power generated with help of gas turbine, another one power we can generate with help of steam turbine. So gas turbine works on base Brayton cycle, and steam turbine works based on Rankine cycle. So with help of the combination of these two cycles, we can produce the electricity. So this is called combined cycle power plant. You got my point, students? How combined cycle is working? What are the concepts behind anti combined cycle? You got my point? Is it clear for you? You have any doubt? Now you can ask. So combined cycle is nothing but a combination of two cycles. One cycle is Brayton, second one cycle is Rankine cycle. Okay. Students, is it
Okay.
audible?
It's audible, sir.
Yes. Is it clear now? So this is very important for your examination. Sometimes this question may be asked, what is meant by combined cycle? That means you have to draw the diagram and you have to explain uh, with the sketches. Okay, this is very important. So the basic concept is with help of thermal energy, we are converted into electrical energy, and finally we can convert into mechanical energy. So here the waste heat is further utilized for power generation. That is the main motto. So waste heat recovery system is used for additional power generation. So this is called combined cycle. So normal conventional power station, normally coal is fired. With the help of that, water get heated up and further steam will be produced. So with the help of the steam we can generate the power. After that, it leaves the hot gases leave the gas turbine. That gas can be utilized for further steam generation, and that will be used for next power. Okay, producing power with the help of that waste heat, we can produce the steam. Again, it will generate power. So this is called combined cycle. So normal conventional power station, okay, we can inbuild the combined cycle. So you know very well about the Brayton cycle concept. So the Brayton cycle is used for steam power. Concept is used in steam power plant or coal-based thermal power plant. Okay, so the various process in the Brayton cycle you know very well. So that is also you want to explain. Okay, what are the process involved? Okay, how the steam generation takes place, and how the power is produced with help of the steam, and how the further steam or waste heat is utilized for steam generation further, and how the power will be produced with help of another one cycle. Okay, so that will be you have to draw some diagram. Here you can see the diagram. So here you can see the seconds, right? So first, with help of compressor, we can create the heat energy. That heat energy can be utilized for power generation in the turbine. After that, again the waste heats come out from the turbine. That will be again used for another one heat exchanger. That is also supplied to another turbine. So we can generate more power. So this is the normal Brayton cycle plant operation. So if you want to increase the Brayton cycle efficiency, you should know three concepts. So by adding intercooling, or by adding reheating device, or by adding intercooling, reheating, and regeneration, okay, concepts, we can improve the Brayton cycle. That is, you are already studied in uh, thermal engineering subject, and also I also teach in the first classes itself. Okay, that is how Brayton cycle efficiency can be improved. Okay, this is the way we can improve the cycle efficiency. And you know the aspects of Rankine cycle is normally it consists of four processes. That is also you have to explain. So what are the different processes in the Rankine cycle? Rankine cycle normally uses steam power plant or coal-based thermal power plant. So how the power is produced with help of Rankine cycle means with help of boiler unit, we can generate the steam. Okay, that steam can goes to turbine and turbine start rotating and power will be generated. Then waste heat uh, goes to the condenser with help of cooling water. That hot gas vapor is converted into liquid state. Again, it will circulate it with help of pump and with help of coal heating. Okay, with help of coal heating, uh, the furnace in the furnace area of boiler. So boiler uh, convert the water into steam. That steam again goes to turbine. So likewise, the cycle is repeated. So by this way, we can operate the Rankine cycle. That is also you should know. So if you want to improve the Rankine cycle efficiency means we can implement three concepts. What are the three concepts are? Lowering the condenser temperature, superheating by you adding superheating the steam at high temperature and increasing boiler pressure. By these three technique we can improve the Rankine cycle. So individually we can improve the performance of Rankine cycle. Okay, based on that you can improve the power and similarly, you can improve the power with help of adding three areas or modifying three areas in the Brayton cycle. You can improve the power of Brayton cycle, or we can say gas turbine power plant efficiency can be improved. And finally, we can combine these two power plant. That is combined cycle. That is Brayton and Rankine cycle. Also, we can improve the power plant. So the concept is okay, it's very simple. We have to improve the power production. So the concept is either we can implement the concept adding of intercooling, reheating, or regeneration in the Brayton cycle, or by adding some devices like lowering condensation temperature and adding superheating devices, increasing boiler pressure based upon that we can improve the Rankine cycle. And finally, we can combine with both two cycles, we can improve the efficiency. So these are the three techniques are used for improve the power plant, that is called combined cycle power plant. So today we discuss about what is meant by combined cycle and how the concepts there is basic concept that is Rankine cycle and Brayton cycle is used for power production, and we combine how much power maximum we can generate, and finally we discuss about the how the Brayton cycle or Rankine cycle efficiency can be improved. Okay, so that's all from now. If you have any questions, now you can ask. So for your examination, so your examination on falls on 20th. Okay, so you have to prepare for your examination. So our topic for the CA 3 is unit uh, 4 and 5. Okay, so kindly prepare for this. And important questions for the unit 4 and 5 I will give you later by maybe on tomorrow I will give you. So you plan accordingly. So you have to prepare, right? So you have to plan for 2 mark and also you have to prepare for big questions also. So that's all from now. You can ask any questions or any doubt you can ask.
So no doubt, sir. Everything is clear.
Okay, so maybe after the CA3, I will discuss one or two problems related to power plant efficiency. So that's all from our power plant subject. Okay. So one or two classes is enough to complete our power plant syllabus. Okay. So you have to plan accordingly. So prepare the subjects and I will post all the PPTs in your Google Classroom. So make use of it.